So this software we are seeing here, or this application we are seeing here is R Studios. What is the difference between the R and then the R Studio? This is R. This is how it looks like. You look at this R as the engine. So whatever that is driving the whole analytical platform is this small software that you are seeing here. Print, welcome, TT to data science lab. Okay. If I enter, look at it. This is an output and this is the code. I'm asking R to print welcome TT to data science lab. Okay, so this is the engine. But because a lot of people find this interface very uncomforting, like they are not comfortable with it. R decided to design an R Studio, a nice graphical interface to be able to make people comfortable in relating with the software R. But this is the actual engine that is driving the whole analytics. I hope you guys can hear me.
Yes, we can.
So this is a software that they built the R Studio on this particular software. So what that means is that when you take your laptop, a fresh laptop, and you install R Studios on that particular laptop, and you start writing your code, it will not work because the engine, which is the R, is not there. So what I mean to say is that you can install R without R Studios. Your analysis will work. If only you can be able to write your code on this plain interface, it will work. But you cannot install R Studios without R because the engine is not there. It's not going to work. Do you understand that one?
Yes.
We got it up to that level. So that's the difference between R and R Studio. And this is how R looked like. Okay, you can see that this is the version 4.5.3 and it came 2026 March 11th. Now, because a lot of people are not comfortable working with this one here. But there are experts, people who use R for a very long time. They prefer to even work over here than the R Studio. So I'll close this one. I'll close the R. Now, because most of us are good with interfaces, they design R Studios for us, which is this software that is sitting on the engine R, right? So if you open R Studio for the very first time, this is what you are going to see. Remember that the R that we look at just few minutes ago or few seconds ago, we saw this. So once you open R Studios, it integrates into R. Look at it. This is R over here. It picks the engine R. So from here, you can drive all your analytics and everything here. Now, what you have to know is that when people open this particular software for the very first time, other people get confused. Okay. People get confused because they don't really understand the interface. So what I'm going to teach you first is for you to understand the R interface. And once you're comfortable with the interface, I think we can build on from that place. Now, when you open R for the very first time, this is how it looks like. But R actually has four windows. But of current or right now, we are looking at three windows here. We have this one here, this one. This is the first window, the very big space. This is the first window. And then here, this is the second window. And here, this is the third window. But let me bring the fourth window. The fourth window is the script, okay? Is the script. The script. So before you get the script, where to write your R code to keep it, it's like a document. Look at it as a Word document where you can type and save it and come back tomorrow and retrieve the same file. You can actually type here, your codes here, but once you close R, everything you have done will be gone. That is why we have what we call R scripts. Have you seen it? You go to File, then what do you want to do? You want a new file. What kind of file do you want? You want R script. Do you understand up to that place? I, I need a response so that I know that we are getting somewhere.
Yes. Yeah.
Yeah. All right. So you click your R script. Now, when you click your R script, the first thing you would want to do is to save it. Save it. You see, this one is untitled because this particular script is untitled. We didn't title it. But I want to teach you how to set a working directory first before we save that particular file, so that the file that we are naming or we are saving will go to that particular working directory that we want all our folders or all our files to be. All right. So you can write a code to actually change your working directory. Currently, this is my working directory. Desktop, a folder called DigiSoc, a folder called second semester, then it's in a folder called Model 4, and then statistics and data science. That is not where I want us to work. Now, you can write a code to change your working directory, but I want to make it easier for you, right? So now, you see this my mouse, I follow the mouse all the way to here. Have you seen it? These three dots. Don't ever forget, go to directory. I want to understand that all of us are here. We want to change the working directory. Okay, we want to tell R that everything we are working with or we want to work with, this is what we want you to look at, to even pick the files or whatever. This is what we want you to look at. So we click on these three dots over here. Here, you click on it, right? Now I have a folder on my desktop. So I click the desktop, and that particular folder, I was trying to do videos for Facebook. And I think is it called R data science course? Yeah. So this is where I want to set as my working directory, because I have my files inside this directory, right? So I open it. This is not all. So after you have opened it, you see that folder R data science all the way. Now, after you have opened it, you have to come to the settings over here, and then you set as working directory. Set as working directory. You click on it. Now, you can see this is a code you would have written. This is a code you would have written if you had wanted to write the code to change the working directory. You see, here it is, set working directory to desktop, Facebook videos, a folder called R, and then this folder. Yeah, this is how you set your working directory. Now, that being said, we can now save this file, this untitled file. You click on it, then you click on save. Then how do you want to save it? Let's save it DigiSoc data science project. And it always ends with a file extension called .r, okay? .r. So we save it in this particular folder R all the way to this our directory. We save it there. So you can see that this changed to the DigiSoc Data Science R project, right? So you set your working directory, okay? Set your working directory, which we did. Now, I'll start from here, okay? This place. This is the script window, okay? People call it source, this particular one. This is where you write your script, so it's just appropriate that you call it the script windows. Here, as I mentioned earlier on, let's say you have a data science project, all the codes will be written. You write it over here, just like a Word document, but it will execute for you because this is the script window. Anything you write here would work for you. The same thing you write here that works, you can as well write it here. Okay, you can as well write it here. And this place is called the console. See, you see this broom? I want to clear it out. This broom here, this broom here. You click on it, it clears this place for you. So this is where we call console. Okay, so you have here You have the script window or the source. This is what is called the console. Okay, the console. And then over here, we call it the environment. Environment. And we have the environment window or the environment. And here, this place you call it output window. Because if you draw your plot, you see your files are here, your plots are here, the packages, everything is here. So we have the output windows, the environment, we have the script or the source window, and then we have what we call the console. Are we together?
Yes.
Great. So now that you understand this, I've already created a script that I wanted to use to teach you guys. You know the difference between R and then R Studios. You have opened R Studios, which you know that R Studios sits on R itself. Then you know that the R Studio has 4 interfaces. Okay, we have the scripts window, then we have the environment, we have the console, which you can write a code just as how you're writing in the script. But the difference between the console and then the script window is that any code you write here, see, 2 plus 5, okay, you highlight and then you run it. That is 8. But once you close R, everything you write in the console will go. We don't want that thing to happen. That is why we have a script, which is like a Word document. We write all our codes, okay? Where I can finish and send it to maybe TT. I can finish and send it to Darlington. And here, I said we call it environment. That is where you have your data sets and all that. It will be here, right? And here, the plot that you'll be generating, the output, all of them will be shown here, okay? Even the packages that I have, all of them are here, right? So now that we understand this, I want to go and then bring the script that I want us to use today. So I'll go to just here. Well, let me see, file. Then I want to open a file, okay? Because I have the script already. And that script is, what is the one? R basic programming. R basic programming. Okay.
It's down. Yeah.
R basic. So I open it. Now, I'll take my time and slowly explain certain things to you. And I will share these things with you just after the lecture, so that after the tutorial, so that you can practice it yourself, one by one. At times when you open R, you will see that things that you may have worked on already, or maybe another project that you have worked on, will be in the environment. It will be in the environment. And you don't want that. So what you want to do is to remove everything from the environment. And that is achieved by writing RM, remove. Okay. What do you want to a list? Okay, is go to write this code, and this will remove everything from this environment. Everything will be gone over here. Everything will be gone. Right? So once you run it, look at it. You see that once you run it, it runs in your console. Okay, there's no error. So if you had files here, it will be removed. Now, you know that if you want to work with data, you have to load the data set. We have to load the data set. And because the reason why we are using this function, okay, load, is because the data set itself is already in R format, which is the RDA, okay? RDA.RDA. If it were Excel, we will not use load. We will not use load, okay? We'll use read underscore, either CSV, okay? Read underscore CSV. But now, for now, since we are dealing with our data itself, the data is in R format, we are supposed to use load. Now, let me tell you something. Here, we are saying that let's get this loaded name is an object, okay? This loaded name is an object. And let's load this data. When we load this data, let's assign it to an object called loaded name. Okay, if you do this, if you just write load, load, and then you call the BB like this. If you do this, the data set will load all right over here, but you can't call it because you didn't assign it to any object. So what you are saying is that once I load this data, I want this to be represented with loaded name. And if I call this name, I'm calling the whole data set. Yeah,
I have a question.
Yes, come in.
Okay, so can we replace that loaded name with something else?
Of course, you can use it like DF, data frame.
Okay.
Do you get it?
Okay. Yes.
Data frame. So I'll change it back to this. Now, so we load this. So this is what I did. And so look here, just look at this environment. Now, if I do this and I load it, see, look at it. So now we have the whole data in the environment, and that data is what? The BB club. Okay, so this is the name. This is the name. Okay, so now that we have assigned the whole data set to this name called loaded name, if you print loaded name, we are expected to get what? This data. Look at it. Okay, we are expected to get this loaded name, right? This loaded name. Now, so since load may return any object name, we use get to pull that object into a new variable called BBB. So now we want to now get this particular name that we created over here, okay? Over here. Then we assign it to this variable called BBB. So this name, we get this name, then we assign it to BBB. Now, so the BBB becomes the whole data set. The BBB now becomes the whole data set. Now, this whole data set that we imported is represented by BBB. Okay? Is represented by BBB. So now, if you want to see the whole data set, the function we use to see it is called head. Okay, head of what? Head of what? Head of the whole data set, which is BBB. So if you run it like this, what happened? I didn't run this one. You have to run this to assign it first. So that works. Then you can now see the head. Look at it. Look how the data look like. The head gives you the few of the whole data set for you to look at. Right? The head gives you the few data sets that we look at. Do we understand up to this stage? We have loaded the data, so we just inspect the data that we have loaded. Do you understand up to this place?
Yeah.
Okay, good. Now, when we say class, the class function tells you what kind or what type of data you are working with. And what did I say the BBB is? That's the whole data set, and we call it data frame. Data frame. The object is a data frame. Okay. If you see data in Excel, all this data, all this one, it is called what? Data frame. So if you tell other, oh, tell me what kind of object is BBB, it is expected that it will tell you is what? Data frame. I don't know if you can see it down here. It's telling you what is data frame. So meaning this BBB is a whole data frame. Are we together? This BBB is a whole data frame. Now, when you say dimension, you are trying to ask R to tell you how many rows and how many columns that this particular data set have, or this particular data frame have. So DIM is dimension, and these are the things you are supposed to be looking for once you import data into R. you are inspecting the data to see how many columns do I have, what is the class of the object. So if you do dim, okay, dim, that will tell you that you have 1,300 rows and then
Okay.
11 columns,
Columns.
right? So it should always be in your mind that RC, row column, it is row column. Okay, dimension give you row column. So I can give you this. I ask you, Titi, what is the 1,300? What did you represent? What will you tell me? R, which is what? Row.
Row.
And then the other one is what? Column.
Column.
You understand?
Mm-hmm.
Now, you have a lot of, you imported your data set. And you have a lot of variable names. Variable names. If you want to know what are the names of the variable, these are variable names. Look at this: choice, gender, amount, frequency, last, first, child, all the way to earth. These things are variable names. This is small data set. You can see it with your eyes. But when the data set becomes so large and you're working, at times you may forget the names of the variables in the data set. What do? You just use the name function. Names of, you call the data frame, another data set, BBB, this one. When you say names, you are telling it, oh, give me the names of the variable in this particular data frame. So you run it. What did you see? It gives you the names, choice, gender, amount, all the way to art.
Okay. So is it that the column section, the column basically represents the variables?
Yeah, these columns, that's a very nice question. Each column represents a variable. So this is choice, okay? Choice, whether you want to go to school or not. Choice. Is it your choice to go to school? Yes, yes, no, yes, no, yes, no. So the choice, this column is a variable.
Okay.
Gender is a variable. Amount is a variable. So a data set is a collection of variables that makes a whole data set. So in your research, the research you are going to do, if you want to use a quantitative methods in your analysis, you are going to design a questionnaire. And each question you ask the individual, that each question becomes a variable in your data set. For example, what is your
Mhm.
age? Okay, then you have age here. What is your level of education? And all those things will form your data frame or your data set for you. So now you are looking for the names of the variable. So you just names, then you put the whole data frame or the whole data frame object into this function. And to give you that, oh, these are the names of the columns or the variables in the data set, as you have mentioned. Are we good?
Yes.
Okay, so question.
Yes.
So, in a typical question like what are the variables, or maybe name the variables, does that mean you have to mention all these things, or there is a specific variable you should be looking out for?
When they ask you what are the variables in the data set, you use the names. When you use the names here, it will give, when you use this particular function,
Mm.
it will give you the names of the variable. Then you write it. So I don't think that anybody will ask you in any data science exam to mention. Churchill,
Yeah.
did that answer you or you didn't get it?
Yes. So you see, I am asking this question because I think for the first trial test that we had,
Mm.
there was a question at the beginning that said that you should state the type of variables, or the variables in the data set or something like that.
Understood.
And
Yes.
at the time,
I remember.
I don't know if anyone remembers.
I remember.
Yes.
I remember. But what the guy,
Uh-huh.
what he was trying to ask you is that which of the variable did you use for that particular analysis? He was not trying to ask you like a generic question that name the variables in the data set. He asked us to do something, and he was trying to ask you which of the variables did you use to achieve what you have done,
Mhm.
right? So you will know
So in such case, what do you do?
because you claim you have done the analysis, you should be able to know because they gave you a question. You read the questions, you look at the data set, and you know that per the question, these are the kind of variable I'm supposed to use to do the analysis. That one really doesn't have anything to do with the software. It has something to do with your understanding of the questions and what is needed to achieve what they're asking you. Can we go on?
Yeah.
Now, we have the data set. We'll look at the dimension of the data. We know that that is a data frame, actually. Now, one of the things you may want to also look at is the structure of the data. The structure of the data. How does the data look like in terms of structure? Okay? In terms of structure. So now, the command is str, okay? Structure for sure. This shows you the structure of the data set, including each variable and each data type. Okay. Else, if not because of the data types, this should be enough. Okay. Not the name, but actually this was the head. This one should be enough because you have actually seen the variables in the data set. But structure is able to tell you the data type, whether this particular data is a string, whether it's an integer, or whether it is a float, or whether it is a Boolean. So once you do structure, okay, str, and you run it, that thing gets messy. So let me clean here. You run it. Let me explain this to you. So this is the structure of the data. Look at it. First of all, it's telling you that this is a data frame, which we asked earlier. This is class. And then you know that the class returns a data frame. Then this also gives you the variables in the data frame. So choice is telling you that choice is a factor variable, okay? We call this like a categorical variable, but I have to look at this categorical variable as factor to be able to use it for analysis. So if the data set is not a factor, but you look at it as a string, it may not run. The analysis that you want to do may not run. You have to cast this particular variable as a factor variable. And then we are going to do that for you to understand. So he said that it's a factor variable, meaning that it's a categorical variable, okay? And it has two levels. What are the levels? The levels are what? No and yes, okay? So it's either maybe it's 1 and 2, but it just give you the few 2, 2, 2, 2, maybe 1 will be somewhere. Do we understand that? 2 represents yes, and then maybe 1 represents no. Do we get it?
Yes.
Yeah.
Look at gender. Gender in most data we collect in Africa, when we talk about gender, we limit ourselves to males and female. So that is why it's telling you that gender is a factor variable. It's a qualitative variable, or it's a categorical variable, and it has two levels. Or it has two levels, either male or female. So because either of these things is coded by either 1 or 2, you can see that we have, so these are females and male, right? It's either female is coded with 2 and male is coded with 1. That is why you have these values as an example of what these levels are corresponded with, right? Now, when you look at amount is an integer. Okay, amount is an integer. Then you have frequency is an integer. This last is an integer all the way. All these are integers. But there is another data type which is called float. It is not here because none of the variables that we have, unfortunately, is a float variable. Float variables are those variables that have decimals in them. For example, Titi's weight, Titi's height, 1.67. That is not an integer, but that is what? A float. An integer is a whole number, for something like 3,000, 1, 11, 2, 0. So structure is able to tell you all these. And trust me, when you collect data by yourself, data is very messy, okay? The real world data is very messy. So this is a very nice data set. It's not even plenty, but there are times that when you collect real world data, all these things will be messed up. You have to fix it yourself. That is why you have to know the type of data types that exist and where each belongs to and how to fix it. If you realize that this amount does not contain decimals, but it's telling you that it's float. So you have to cast it back to integer. Okay, there are ways we do that. Do you get the structure? Do we understand it up to this stage? Because if Johannes give you data set and gives you 2 hours to do analysis, you have to do all these things. You have to do all these things. Other than that, if Titi is able to do her own and then maybe gives you part of the code without this data cleaning, or gives you her code from the analysis stage without data cleaning, you run that code, it will not work for you because Titi may have done data cleaning, assigning proper variable types, coding, and all those things before getting to the real analysis part of the whole thing you are trying to do. Because data analysis is divided into 3. We have data cleaning, then the analysis itself, and then interpretation and report writing. You can't jump, or you cannot fail to have knowledge of data cleaning and say you are a data analyst. And data cleaning takes 70% of all your workloads when it comes to analysis, when it comes to the whole data science pipeline. So you really, really have to focus or waste all your times here. You look for outliers and remove them. We are going to talk about outliers once we move forward. Are we good with structure?
Yeah.
Yes.
Good. Now, the next thing we want to talk about is variables and object assignment. Variables and object assignment. Let me clear this and bring this down a little bit. Then we'll understand. Variables and object assignment. Now, in R, this student name is an object, okay, or it's a variable. Now, so what I want you to know is that look at this, just look at this arrow. This arrow should be able to bring your mind to something. I am saying that I have this student called Amma, okay, and I am assigning this Amma. Look at where the arrow is going. I'm assigning Amma to student's name. So what is student name?
So student name becomes an object.
So what is student name? When you say student name, what is it?
Amma.
It's Amma.
Yeah.
You get it? Now, we say student age is 22, and we are assigning student age. We are assigning this 22 to student age. What is student age? 22, right? Then
Right.
we have whether has the student passed the exams, and that variable or that object, we call it student passed is a true or false question, or student passed is a true or false question. And true, we are assigning true to what? Student pass. So when you call student pass, it should return this value for you. Let's run it. So I will highlight all of them and I will run it. You see, we assign Amma to student's name. 22, we assign it to student age. True, we assign it to student pass. Now, the questions I was asking earlier, if I run student name, what do you expect which output do you expect?
Amma.
Exactly. So see, student name. What is this? Amma. When I run student age, is what? 22. If I run student pass, you should see true. So this is how we assign objects, okay, or we create variables, right? Are we together?
Yes.
So now that is how we assign variables. So I think that with practice, you get to understand the whole concept of what you are trying to do and see that
Let me put in a question.
yes, Darlington.
Yeah, is there any peculiar meaning to the color of the at the console portion? There are some scripts that are in color move or whatever, and others are in color black. Is there any explanation to that?
These are themes. Okay, I can change this. Okay, if I go to tools and I go to global options, okay, I go to global options and I look at appearance, right? I can choose this. Okay, first it was at, let me cancel it, and you go to tools, you go to global options, you go to appearance. It's at Chrome now, but you can change it to what suits your eye, right? So
Okay.
you see, if I do this and you apply, it will change my whole interface to this, and the colors will change. So it's just a thing.
Okay.
I don't want this because it's not pleasing to my eye. So I'll go back to the global option, go to appearance, and go to my Chrome, and I apply, and I come here.
Okay. Very well.
Right. So we want to talk about data types. And these pop up earlier. Well, we are talking about the type of data types that we have. Now, R itself have various data types, okay? And the most common ones that you'll be seeing is we have numeric, we have character, we have the logical operators or logical, okay? True or false is a logical. And Python will tell you Boolean. Python call it Boolean, R call it logical. Now look at this. So if I write 85, what is happening here? What are we doing here? Titi, can you tell me what we are doing here with this code? What are we doing?
You are assigning 85 as the score.
Exactly. We are assigning 85 to score. So if I want to find out what is the data type of this score. Titi, what do you think the answer will be? What is the data type? What do you think the answer will be?
Numeric.
Let's see if it is numeric. So let me assign this. So we assign the 85 to score. Now we don't have to call the 85 because if you want to call the 85, you call the score because the 85 is inside that score. So now let's see, what is the class of that 85, the score? What is the class? TT say numeric. So we are clapping for TT, numeric, right? Now, Churchill, is your time. Oh, yeah. So we have course, and the course is what? R programming. And when you are writing a test, you have to what? Put double quotation around it, right? You quote it,
Yeah.
double quotation, because you are running a test. So let's run it. Chacha, what do you think the class of the course will be?
To be character.
Exactly, character, because is what? A test. That is why this factor thing comes in, because at times when you have like sex, male and female, if it is not well coded, that male and female, or sex as a variable, would be seen by R as a character, meaning was supposed to be a factor. So you have to cast the character into a factor. It is something that we'll look at later. Darlington, so we are asking whether let's say the student or the individual is present in class or not. So we say yes, true, is present. Darlington, what is the class of is present? Is he there?
Hello. Okay.
Yeah, what is a class
It,
of is present?
it's supposed to be the same as character.
Are you sure? Look at this. Look at what we are assigning to is present. We are assigning, yes, true. The individual is present in class. Okay. Now, what is a class here? Do you remember logical? So I'll run it and you see that it is logical, right? It's logical. Okay, true or false? True or false is logical. True, false is logical. Okay. Now, are we good?
Yeah.
Yeah.
So now we look at vectors. Vectors. Okay. So now a vector, we say it's a collection of values, okay, of the same type.
Okay, Kingsley, let me just backtrack a little bit. So that means that when we are talking about data types in R, the three main types we can look at is the numeric, the character, and then the logical, right?
You can add what's the name? You can add this into a factor.
Factor, okay.
Factor. You can
Okay.
add it because those are the things you really be working with. Okay. And then
Okay.
yeah,
What would be an example of a factor variable?
I mentioned earlier that factor variable is just like a character, but if you want to conduct something like maybe inferential statistics, like regression and all those kind of things, odds ratios and all that, the model would want you to convert that character, that sex, male and female, which can be seen as a character, to how did I say, to factor before you put inside the model. You get it? It's so the factor is in such a way that those labels that you see as male and female, they are actually numbers, 1 or 2. So the model will be able to understand that there are numbers under those labels, male and female. But you, the human being, you need those labels to be able to understand that this is a male, this is a female. But those numbers under those male and females are what is used by the package, the statistical software, to be able to run your models for you. The models are not running on males and female. They are running on the numbers that are behind the males and female. Are we good?
Yeah.
Can we move?
Mm.
Yes. So as I was saying, vectors, when we look at vectors are collection of values, okay, of the same type. What that means is that you cannot create a list. I'm forced to call it a list because it's a list of numbers. Okay, list of numbers. Python call vectors as a list, but R call it what? Vectors. That is why you have 70, 80, 90, 85, and 75. And these vectors are concatenated or combined by bringing this C in front of them. Okay, so we have marks. How many? Let's say we are 1, 2, 3, 4, 5 in this class, and they want to record our marks. Okay, they want to record our marks. They want to put our marks together. So R demands that you create your object name or your variable. Then you are saying that into this variable, that arrow into this variable, I want you to put all this together, all these marks together. And that statement, I want you to put all these marks together, is represented by C. And they say, what does it mean? Concatenate, like bring them together, like join them. Whilst you are joining them, you are supposed to separate them by commas. 70, that's for Churchill. 80, that's for me. 90, that's for Titi. 85 for Zanu. 75 for Darlington. Okay? Like this. So once you run it, Mark, when you call Mark, what do you think will come? When you call Mark, what do you think will come? Do you think 70 will come, 80 will come, or you think that it will bring the list of everything because we concatenated them, you add them together? What do you think will come?
Everything. A
Every
list of all the numbers.
yes. So when I run the mark, look down here. When I run the mark, you see that it brings 70, 80, 90, 85, and 75 because we bind all of them together with that C, concatenate, add them together, right? Now here, so this is numeric, okay? Numeric vector, okay? Because it has what? Numbers in between them. Numbers in between them. So we have character vectors as the name explained. When we look at what characters are, and we all know that characters are tests. And I told you that when you're dealing with tests, you have to put them into quotations, left-right quotations. So name vectors or names vector, we are pushing, look at the arrow, we are pushing all these things into this container, okay, which is called name vectors. And we are combining, okay, Ama, Kojo, Yao, Amina, Linda, okay. We are bringing all of them together. We are concatenating all of them together, and we are pushing it into this container, okay. We call it object, or we call it variable, okay. We are pushing it to it. So once we do that, we run it, and you call names. Don't forget that we have put all these things into this container, okay. This is a cap. And you put all these things inside it. So when you bring the cap or when you run the cap, you should see all those tests or all those characters you put into that particular vector, okay, character vector. Are you together?
Yeah.
Good. Now we look at it, logical data types. Logical data type, which are true and false, or true or false. So when we want to create a vector for this logical data, true, false, we just write, we create a container, okay? I call it container. You just look at it as a box. And within box, we have 1, 2, 3, 4, 5. I want you to combine all this one, true, false, combine them together with the concatenate, the C, and put all of them into this container for me. And now when I call the container, I am expecting that everything that is inside the container should come out. You see, when I call the container, I'm expecting that everything inside the container should come out. So we are creating a vector, right? Vector, logical vector.
I have a question, please.
Please come in.
Okay, thank you. With regards to the inverted colons,
Commas.
this you said for every character, you have to use them, right? So, does that include, how do I say this? Does that include, even when you're not calling the character, when you're not calling it like a vector? I don't know if what I'm saying makes sense.
Yes, I understand what, yes. Anything that
Okay.
is a test, wrap it within those two quotations. Anything that is
Okay.
a test.
That is a text.
Yeah.
Now, for this logical vector, true. So we're saying true and false are no longer text because of what they represent in this context.
Because once you write true, the software is programmed in such a way that once you write true, it automatically sees it. We call something reserve words, okay?
Okay.
Words. So the system understands. Once you write true, it knows that you're not writing English.
Okay. Okay, you get it. That's my question.
You get, yeah, it knows you are not writing English.
Okay.
Now, you have seen that we have created vectors. Now we wanted to look at what is a class of these vectors. So I'll start from you, TT, again. You remember we created marks Remember, right? We created
Yes.
mark.
Yes. 70, 80. Yeah.
So now you know that if you want to know what kind of class what you created is, you have to bring class, and then you bring your object into it, right? So when I ask that what is the class of mark, you just write class and then you run it. And this is what? Numeric. Why is it numeric? Because we have
Yeah,
Numbers.
numbers.
inside it. Numbers
Yes.
inside. Do you know that if I somehow put these things into quotations, Titi, based on the question you asked me, what do you think will happen? What do you think it is?
It will change to character.
Exactly. It will change to characters.
Interesting.
Even
Even though they are numbered.
so let's try it. Let's try it up. I ran it. It ran all right. So now when I ask what class is it, Titi got the answer. What is it?
Wow. Character.
So you have to know when to use the quotations. Okay? You have to know when to run. And then this, it doesn't mean your life is over. When something like this happens, doesn't mean your life is over. You can cast it. Okay, as numeric. Then let me do that for you to see. So we have, let's say max 2. Okay, like this as dot numeric, right? As numeric. What do you want to convert to numeric? You want to convert this particular thing to numeric, right? So let's run it. You see, now, if I ask that what is the class of, what are we looking for? Mark what? Mark 2. What do you think would be? It was character before, but now when you run it, because we cast it, it will tell you it's numeric. Do you now understand that when such thing happens in your data set, it's not the end of your life. You can cast it. You are saying that, oh, okay, I understand that you are looking at what I thought is a number or was a number as a test. But now, no, I want to create another variable. And whilst I create this variable, I want what you are saying to be a test, which I want to be a number. I want you to cast it now as a numeric, right? And that's what's happened here. Are we good?
Yeah.
Professor Churchill.
So let me get this. So it means that if you want to cast it, then it means that whatever the object is, you need to put 2 in front of it, right?
What?
And then I mean the code.
You can give it any name. You can give it any name. You can give it any name. But I just want you to know that this is the original and then this is the second one. So I can just give it, let's say, casted max. You get it? Max. Okay, because
Okay.
I casted it. Anything. You just have to know what you are doing. Are we good?
Okay. Yeah.
Okay, sorry. I want to ask another question. Now we've checked and the class is back to the character, the vector rather, is back to numeric. Is it possible for you to recall it and for you to run it rather, and in the console we're going to have the numbers 70, 80, 90, 85, 75 without the inverted colon. Do you understand what I'm saying?
Like something like what you have done here, something like this.
Yes, without the
Without, of course, if you do look at it here, all that you have to do is to call that particular. The reason why you saw numeric was we're calling class on it. But if you do this, Mark 2, your question is answered. Is that not it?
okay, good. Yes, that's it. Yeah.
Right. Right. So now, at times you want to know how long the length of the variable or the length of the vector we are working with. There's a function in R called length, just length. Okay. Maybe if I run it, you understand. Mark, length marks. Titi, let's count. 1, 2, 3, 4,
4, 5.
5. Okay. At times, these things will not be just few for you to be able to count with your eye. You need a function to do that. And that function's name is called length. Where is it? Length. So you want to see, oh, how long is that object? Okay, that container. Those things inside, how many are they? You just run it, length. Did you see it?
Yes.
5. 5. So this is a lot. It's a lot to take in, really. It's a lot to take in, but you have to be practicing. You will forget. You will forget. And the reason why you forget is that you are not a data analyst. If you are faced with challenges, if you are a data analyst, you are faced with challenges, you research, or you are doing this thing over and over again, you will not forget. Okay. At the time when you forget, it's easier for you to search because you know exactly what you are looking for. But if I leave you now that go to the internet and then solve these issues or these challenges for me, it will take a much longer time because, in fact, you don't even know what you are looking for, where to even start from. Okay, so let's go. Let's do some simple calculations. If I run this, I'll get an error because we cannot run summation on this, okay? Because it's using this, not 2.
Yeah, not 2.
So let's see, we should get an error. What did you see? Invalid type. Okay, you cannot run sum on this. So let's go back. Is Darlington online? I'm interested in knowing.
I'm online. I'm following, Pa.
Good. So I'm removing these quotations that I've put here to show you. I'll remove it. I don't want to use the Mark 2. I just want to rerun this. So now this is numeric now. So if you have a variable, let's say age somehow, or let's say sales, you have each individual sales and you want to have the total sale, there's a function called sum. We all know what sum is. So you just have to call the sum function. Look at it, sum. And what do you want to sum on? Which variable you want to sum on is what? Max. And when you sum it, let me clear here. When you sum it, you should get the total, right? If you don't trust me, you go back and add all these things together. You have 400. Now we are getting to what we've been doing in school. Now, if they ask you to calculate the mean, you just have to write the mean as a function. And what are you calculating the mean on? Is the max. But maybe exam to be the mean age, right? So you just put the mean of what? The mean of max. That is the average, right? You just give it. That's 80. Titi, are we good?
Yes, we are.
Yes. Now, if they ask you what is the minimum, this thing came in that test we did, the minimum, the maximum, all those kind of things.
And I failed it woefully.
Oh, sorry. What did you get?
Do I even know what I was working with?
Sorry.
Oh God.
So they ask you of minimum. What is the minimum? Let's look for it with our eye. Titi, what's the minimum? It is. So before the other video ended, so minimum, I was trying to ask you, if you look through these marks, what is the minimum marker there? That should be 75. Right. So if you call
Is it
minimum,
not 70?
would you have
It's
7?
70. The first
Yes,
the
there's
first number is
70.
70. Mm.
So what do you expect? Minimum is what? 70.
70.
You can see it there. The same applies to maximum, and that is what? 90. Now look at this function, round. Round. Look at this function, round. It's trying to round the result to a certain number of decimal places. So here is it. So this is two functions together. The first function is here. The first function is mean, like this. And the second function is round, like this. Now, because we want the mean to be rounded to a certain number of decimal places, we use the round, okay? The round function. We open and close it. Then we want the mean of what? The mean of max, okay? The mean of max. Now, how many decimal places? 1 or 2 or 3 or 4 or 2. Do you understand? Do you get it? It's a little bit complicated because this is two functions brought together, right? So let me do it.
So in a nutshell, we see the round as a nested function because it has the mean in there. So
Exactly.
you are rounding the mean, right? The mean for the max
Then you round it
to
up.
2 places, right?
Exactly. So I like the word nested function because that is what it is. Titi, Darlington, do you get it?
Yes, I
I'm
do.
following.
Exactly. So the mean we calculated earlier, let me see. Let me go back to calculate the mean for you. So the mean is exactly 80. But if you run it to two decimal places, it will be 80.00. So let's do that. Round the mean to two decimal places. What happened? Well, I don't know if ideally it's supposed to be 80.00 because we are rounding it to two decimal places. But because the reason why this didn't work is because this is numeric. If we had, let's see, testing float, right? Then this C 2.3, 1.8, 4.7, then we have 2.0, 1, 2, 3, 4. Let's add 1. So you have 0.9, right? If I run this, and let me say, what is a class of this? Let's see. What is a class? It's seen as numeric. It's seen as numeric. Let me see something. Testing float. What did I even write? Float. 2. This as dots. Do we have floats? We don't have floats. Maybe I'm confusing Python to this. But however, let's see the mean. Okay, now let's round. Okay, let's get the mean of this, like this, to two decimal places and see what that will be. What happened? What did you say?
Added
If there
2.
is 2,
Float
Added
2.
okay,
Yeah.
to be this. Titi, you are understanding the thing.
You're a good teacher.
Thank you. So look at it. I don't. It's float 2. I was expecting 2 decimal places, but at the end of the day, this is what we got. You got the concept of rounding, right? You got it, right?
yeah, because if it is more than more than 4, then it rounds it. It might end up rounding it to the nearest whole, actually.
Right. Let's just accept that, and then we move on. So there's something we call indexing. Indexing. Let me see. We call the head of BBB. Yeah, let me call this the head of BBB. There are times that you are just only interested in maybe just these years for whatever reason, just this years for whatever reason, or just this column, okay, for whatever reason, okay, just this years, or maybe male for whatever reason. We are able to achieve those operations by what we call indexing. Now look at this. I always confuse Python with R sometimes. So maybe the first attempt of what I'm going to tell you here may be wrong. In Python, the very first element, either in a list, in a tuple, or whatever it is, starts from 0, okay? 0. So let me send you back to max over here, right? I will run it. In Python, it starts counting from 0, 1, 2, 3, 4, right? But R, let's see what happened here. If you want to call the very first number 70, for some reason, you want to extract 70 from this particular object, you index it, and that is achieved by bringing the name of the object, then you give it the index position. Let's see. Let's run it and see. I'll be able to explain better with what we get. What do we have? 70, right? So meaning that whilst Python starts counting from 0, R starts counting from 1. That is the difference between indexing for this particular two softwares. Do you understand? So R starts counting from 1. So because this is index position 1, this is index position 2. Titi, if I want to extract 85, what am I supposed to do? Look at it and tell me.
That would be
4.
4.
Let's see if that is true. So Titi said max. Then you bring the square bracket. Then you give the index position 4. That's what you said. And let's see if we get our 85. And that works. It makes sense, right?
Yeah.
Yes, just don't forget. Don't forget. Just don't forget. So index position. So the same, if you want to get the third element, what is the third element there? The third element, 90, right? So you call the name of the object, you put into square bracket the index position, right? So you run it. You get your 90. Now, remember I told you that when you are looking at rows and column in any statistical package, it should be in your mind, RC, row and column, row and column, row and column. But here, see, it's always like this. Let me see. I don't want to confuse you. We can, if we that data set, the BBB, BBB, if you wanted to extract data from BBB, we can do something like this. 1:3, comma, then let's say 1, 2. What this means is that this is row. It means that from row 1 to 3, right? Row 1 to 3, and then column 1 to 2. Let me not confuse you. Let's get here. So what we want here is that the marks I want from 1 to 3, right? 1 to 3. Let's run it and you see. Here, what that means is that marks, I want the first, second, and the third element in this particular vector. That is why we have marks 1 all the way to 3. Does that make sense?
Okay, so that means that in this this particular output, it is looking at it as a range.
Yeah, from 1 to 3. I want to understand you understand this, because
Yeah.
you'll be building up on Darlington. Do you understand?
This one there,
Okay.
it is the practice.
I'm
It is
following.
the
I'm
practice
following,
that we
Paul.
have.
Yes. So just small and practice. If you have your time, you practice to make sure you understand it before we go for the next one. That's how you build upon it, small, and we are good to go. Right? Now, let's move to vector operations. You remember the marks. Let's call the mark and remember ourselves what is inside the mark. I just selected only the marks and I ran it. This is it. Titi, or let me ask Darlington. Darlington, if I said mark plus 5, what do you think will happen? Churchill, what do you think will happen?
Well, I think that it will add 5 to all the marks, all the list of marks that we have.
Exactly. That is the answer. That is the answer. So this will become what? 75, right?
Yeah.
This will become
85.
85. Exactly. All the way
95,
to 80.
90, and then 80 again.
You got it, right?
Yeah.
So if you say, Titi, you got it, right?
Yes.
So if you say mark times 2, meaning that this will be what? 140, 160, 180, whatever this is, all the way to the end. Because we are multiplying each element in the vector by 2. Are we good?
Yes. So I have a question.
Ask.
Why can't it be? Oh, okay. I think I've answered it in my head. Because I'm thinking, why can't it be the sum of all this plus 5? Then I now realize that the function, there is no sum in the function. So yes,
You're just
it's
adding
fine.
5 to everything, right?
Yes. Got it.
Now, anybody who answered this question, I'll be owing you 20 euros. So what will happen is that what you will get is a 70 greater than 75? Yes or no? True or false?
False.
False. So you get false here. Is 80 greater than 75? What do you get here?
True.
Is 90 greater than 75?
Oh no.
What will you get here?
True.
True. And then this one is what? It's not greater. It's what?
False. Yeah.
So all of you, when we meet in summer school.
There's no way I could have even guessed right.
Okay.
So my question is, what makes it a logical variable?
Greater than and less than, those are logical operators, right? So let's look at metrics. Okay, metrics. Metrics is, let's say something is metric. It's like rows and columns, rows and columns. So look at this. We have 70, 80, 90. How many are they? 1, 2, 3, 4, 5, 6. It's just telling you that take these numbers, then the number of rows I just want 2 rows. If you have 2 rows, the number of columns, I want 3 of them. Okay. So let me run it. I think you understand better if I run it. But don't forget that the function is matrix. If you want something in a matrix format, the function is matrix, and you are storing that in a container or in an object called scores matrix. So let's run it. We'll run it here, and I'll better explain to you. Let me clear that down here. So I run it, and then it's run. Let me show you now. Let me show you the content. Okay. I do that by running the object that we assign it to. We run it. Look at it. Now, let me explain. We have 70, 80, 90, 85, 1, 2, 3, 4, 5, 6. We are saying that we want what? How many rows? 1, 2. And then how many columns? Number of columns. N calls, number of columns. 1, 2, 3. So is it how we structure the data for you?
Yeah.
So that is matrix, 2 by 3 matrix. So now, if you are not sure what this is, or in fact, if you want to check the dimension of the matrix, what do you think you have? 2 by 3. Look at it. 2 by 3 matrix. Have you seen it? What is the dimension? Is 2 by 3. How do you access data from the matrix? So remember, this matrix is called scores matrix. So you bring it, okay? So you want the first, we want the first, what's in RC, the first row. So let's, first row, first column. Look at it. Where is it? What is the thing? First row, first column. This is first row, right? First row, this is it. And you want the first column. This will retrieve 70 for you. What is in first row? The first row, this is the first row, right? This is the first row. But what is in the first column? This is 70. Let me run it. You get? Okay.
So, okay, how different is this one from the one that we tried where we used the 1:3? How different is that?
It should, that is a vector. We're applying that indexing on a vector, okay? A data space level. But this is a matrix.
Okay.
And matrix is made up of rows and columns. So you can't just use just row. You have to combine the rows and the column. So now that I explained this to you, if I want to retrieve 85, if I want to retrieve 85, what should I write?
Row 2, column 2. That's 2, 2, 2.
So let's see what it is saying. So row 2, column 2.
Oh.
It is a good student. Let's run it. Did it work? So it means that you understood metrics and then how to access values from metrics. Are we good?
Yes, we good.
Sure. So we have, you remember that we were dealing with vectors. We say you don't mix text with numbers. Do you remember? But we have another data type, okay, that you can mix those. You can mix text, you can mix what's the name? Logical. You can mix numbers with them. And that is what is called list. So within this list, okay, so a list can store different types of objects, okay, together. So we have student list. And we have this function called list that will make R understand that what we are dealing with is actually a list. So now, within that list, we have name. The name is Amma. Age is what? 22. Whether she passed, we have true. And then the marks, we have a combination or concatenation of 70, 80, 90. Let's run it. And you see how it will look like at the end of the day. Don't forget that we created an object called student list. Then we are assigning all these things to the student list, And after that, we call this, because this is what we assigned to this, to give us this. So here, I run it. Let me clear here. Then student list. Look at how it looks like. You see, name is Ama, age is 22, pass is true, and then marks 70, 80, 90. Now, this is what you really be doing. This should look familiar to you, because this is what Johannes have been doing in class. You see that he brings the data set name, he brings $sign. Do you remember?
Yeah.
What that means is that he said, okay, I have a data set which is called student list. And within that student list, I need you to retrieve a variable which is called name for me. So that is what he's doing. So remember that data set, something like this. BBB is a data set, right? This particular data set that is showing. And if I want to retrieve gender from this particular data set, I bring the $sign, you see? Then this $sign will invoke this IntelliSense, which will show me all the variables in it. So once I pick gender, and I run it, I should have only gender. You see, I should have only gender displaying. So let me clear this. In this, our data set, student list that we have run here, if I call the student list, which is considered as the whole data set, and I want to retrieve name from here, Titi, what do you think I will get? Look into
You get Ama.
Exactly. Look into the student list data set that I have and bring to me the variable called name. And that variable called name should retrieve what we want, which is Ama, right?
Mm-hmm.
And again, look through that particular data set, okay, or that list. And there's a variable inside called mark. Bring that one for me, right? And this is 80. Are we good? I want to end the class here. I hope today is not too complicated, and then you have amassed some level of knowledge when it comes to basics and the foundation of R.
Yeah.
I'm allowed to believe so.
Yeah.
Yeah, so the truth is, yeah, just as you rightly mentioned, we need to practice. I think that's the bottom line.